And here I am once again giving up my lunch break for you. Y'all just don't deserve me. Actually, you do deserve me. You do deserve somebody who's willing to give up their lunch break for you. It just gets old. Do better. Make good grades. All right, find the simplified product of x minus 4i times x plus 5i. Actually, the reason I have this in here is because it basically nullifies your calculator. To some degree, it does. So that's why I put it in here. Of course, now if Jesus saw this, Jesus would foil. If you're ever going to ask yourself, what would Jesus do? The man would foil. So x times x is x squared plus 5ix minus 4ix, because that's what it is. 5i times x is 5ix. Negative 4i times x is negative 4ix. And then we have the negative 4 times 5i, which, has to be negative 20i squared. Has to be. Just has to be. Combine like terms, we'll have x squared. 5 minus 4 is 1, so just plus ix. You can put the 1 there if you want. And I do know that a lot of you guys struggle with this. Just remember that I squared is negative 1. So a negative 20 times a negative 1 is positive 20. And I've shown you in this class, throw it away, change the sign. That's all you do. And there you go. And if for some reason you cannot remember what negative 20i squared is, even this old calculator can do it. Negative 20i squared. Oh, it's 20. Oh my God. Who would have thought? Use your calculator to find the cubic function of best fit. That's probably Friday's lesson. Let me go get a better calculator. Sorry, not Friday's lesson. That'll be the lesson I teach Thursday. Tomorrow, actually. Unless you're fourth period. Fourth period might get taught part of that Friday. I don't know. Things move so slow in that class. But anyways, it's not hard. It's the same thing we've been doing. You're going to throw your x's into list 1. And you're going to throw your y's into list 2. Then you're going to go to stat. You're going to arrow over to calc. And because it's a cubic function of best fit, you're going to do cubic regression. That's all you're going to do. It's one of those easy problems. So stat, edit. Let me clear out all my stuff. All right, let me turn down the contrast so you can see. Stat, edit. There we go. Your x's go into list 1. Your x's being 3, 5, negative 2, and 6. And your y's into y2, 0, 20, negative 3, and 5. 0, 20, negative 3, 5, 3, 5, negative 2, 6. You quit out. I don't think you actually have to quit out. Stat, calc, cubic regression. Scroll on down to calculate and press the enter key and ta-da! Who knows how far I'll round this? It'll obviously be multiple choice, which, doesn't mean anything. Some of y'all still be missing it. Negative 1.2, let's say 0.95x cubed. I'll go out 4 decimal places on the twin. B is a nice number, 8.6, plus 8.6x to the second. C is fugly, plus 0.4667x, and then plus D, minus 46.1429. And that is how you form a cubic function of best fit. It's really easy to do. 17 is an old problem. During ancient warfare, it was common to launch plague-ridden dead objects, especially ones that were rotten, into fortifications that were under siege to cause death and disease. A lot of times you would actually make your enemy lose the will to fight. They're too sick. But anyways, blah, blah, blah. An equation is given to you, not even asking you to form it. It's negative 4/10 of t squared plus 90t plus 18 That equation is obviously flawed. But anyways, who cares? Just go with it. I modified it quite a bit. How high in the sky will this plague-ridden projectile of death get? That happens at the vertex, and we'll do it by hand. We'll do it in TID4. By hand, the x value is opposite b, so that's negative 90 over twice a, 2 times negative 4/10. That'd be negative 90 over a negative 8/10. 900 over 8 be 100 and what? 12.5? I want to say it's 112.5. I feel like it's 112.5. So 90 divided by 0.8. Ha 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 ha. 112.5. Anyways, that's the x value, right? This is the actual time because it's t. T is for time. So to find the y value or the height value, I plug in 112.5. And I can't do that in my head. So 0.4 times 112.5 all squared plus 90 times 112.5 plus 18. And let's just see what that is. 0.4 times 112.5 all squared plus 90 times 112.5 plus 18. Wow, 3 miles basically. 15,205.5 feet. This is a very unrealistic problem. I do hope you understand that. It's just something I made up. 15,205.5 foot. Part 2 is over what interval of time will this plague-ridden carcass be above 200 feet? I'm going to do this by hand because that is the goal. All right. So we're going to put a 200 there. The equation is going to be greater than that. And then I'm going to work it out. All right. I'm just going to work this thing out. I'm going to shift everything left because I want that 4/10 of t squared to be positive. I'm going to pull a 4/10 out of everything because everything is actually divisible by 4/10. At least it should be. Take 90 and divide it by 4/10. You'll get a decent number. Should get a decent number. 90 divided by 0.4, 225. So minus 225t. You take 182, you divide it by 0.4. You'll get a decent number. 455. Now, I don't even know that I had to do that. I just felt like doing it because I like whole numbers. It was optional. You could actually go back here. In fact, it actually probably makes more sense just to go over here and do A is 4/10, B is negative 90, and C is 182. I shouldn't be trying to confuse you with that. Anyways, I have no idea how that factors. I don't think it does factor. So I'm just going to do the quadratic formula. So x would be opposite b, which is 90 plus or minus square root of a 90 squared minus 4 times 4/10 times 100. Oh, you can't see anything. Something happened there. 4/10 times 182. All over twice 4/10. About the only calculation there that I can do in my head is I know that 2 times 4/10 is 8/10. It's about all I can do. Let's see what happens when we do 90 squared minus 4 times 4/10 times 182. It would be amazing if this came out with something with a perfect square root. It's not. It's 88.37. And both pieces are over 8/10. So 90 divided by 0.8 is 112.5. Feel like we did that earlier. plus or minus 88.37 divided by 0.8, 110.46. Now, if you think about the context of the problem, the dead thing go up, dead thing go down. Since I set it equal to 200, I found an intersection here and an intersection here. These are both valid answers because of the context of the problem. So I take my 112.5 and I add 110.46 and I get 222.96. If I subtract 110.46, I get 2.04. And the time is simply stuck in between those two things, roughly between 2 and 223 seconds. All right. 3, you set your trebuchet to hit a certain target 80 foot in the air. How many seconds until you hit said target? It is basically exactly like number 2, but you just use equality. 80 is negative 4/10 of t squared plus 90t plus 18. And again, shift left, 0.4 t squared minus 90t plus 62 is 0. Now I'm going to do a second video on this, a lot of these problems where I go through and do it in the calculator. So that's coming too. But this is the work, which is the goal of the class. The work is the goal. So I can do the quadratic formula again. X is opposite b, so 90 plus or minus square root of a 90 squared minus 4 times a, which is 4/10 times c, which is 62, all sitting pretty over twice a 4/10. So I got the 90 over the 8/10 again, which is 112.5. I won't have to push that in a calculator. And let's see here, we got a 90 squared minus 4 times 0.4 times 62, 8,000.8. And when I take the square root of that thing, 89.45. It's also over 8/10. So 90 over 8/10 was 112.5 plus or minus something. 89.45 divided by 8/10 is 111.812. And one of these answers doesn't make sense. It doesn't. The first answer you get is when you hit 80 feet the first time, because you're talking about y is 80. One of these answers represents that, and one of them represents this one, and that's the one I want. I actually want the bigger answer. So 112.5 plus 111.8125, about 224.3 seconds. The other thing is extraneous. It is. It doesn't make any sense. Man, it's almost time for 6th period. Let's see here. At what velocity does the plague-ridden carcass hit the target? Here's what I know. I know the time is roughly 224.3 seconds. Okay, that was the target. I'm going to have to find f of x plus h minus f of x all over h. And I'll let you guys figure this out, but this ends up being, I know shortcuts by the way, negative 8t plus 90. That's actually what that is. F of x plus h minus f of x over h ends up being negative 8t plus 90. And, you know, you do that, you'll see it. If you do your work right, that's what it ends up being. It's something up here. But anyways, that's what the derivative is. Negative 0.8 times 224.3, add 90 will be the velocity of this dead thing. Negative 0.8 times 224.3 plus 90. Don't be asking Mr. Milbrath how he did the shortcut there, because I ain't going to show you. Well, that's actually not too bad. I would have expected it to be a lot faster than that. I didn't make a mistake, did I? Took my equation. Negative 8t plus 90. Yeah, I would expect it to be faster. The reason this is so low is because the problem is apparently not based on this planet, because it's saying the pull of gravity is not what it's supposed to be. It's supposed to be negative 16t squared. It's saying the pull of gravity is 8/10 of a foot per second, which on Earth is 32 feet per second. So anyways, it's moving 89.44 foot per second. I wish I had time to finish this today, but turns out I don't. That sucks. So there'll be another video. Yay. Actually, there'll be two more. One more where I finish this thing, and another one where I show you how to do it all in a calculator. Or at least what you can do in a calculator.